This lecture is about sampling. Sampling is an issue for any kind of research, but is particularly appropriate for descriptive research and for causal research. Remember that research is done to answer a research question. The question is about a population. So in marketing, typically we're answering questions about all consumers in the target market or all firms that a firm does business with. So the sample is some subset of that population. So the terms that relate the sample to the population. Population is everyone under consideration. Sometimes the term census is used. Census means a measure of everyone in the population. The sample unit is the definition of the individual sample member, whether that's an individual person or a household or a firm. And the sample frame is a list of all of the sample units. It's a list of all the units in the population. So if you had a list of the names of everyone in the state of Washington, that would be a sample frame for the population of the United States, or of the state of Washington. And from that list, a sample could be drawn. And the sample, of course, would be a subset of that population. The good samples, of course, have the criteria of being valid and reliable. And that, in a sense, they are valid and reliable measures of the population from which they are drawn. The validity of the sample refers to the extent to which the sample represents the population, so that it is a fair characterization of the population. And it is affected by sample size. You can imagine if you had a population of 100, a sample of 99 would give a very fair representation of the population. And a sample of 2 would be much more problematic representation. Validity is also dependent upon the sample frame. Remember that the frame is a list of the members of the population. And by that I don't mean a hypothetical list, I mean the actual list. So with that population of 100, we are almost never able to get a complete list of 100. So maybe our sample frame has 90 members of the 100. And so the validity of the sample that we get depends on the validity of the sample frame that we're using. And we need to be careful in evaluating sample frames. It's very, very difficult to get a complete list of all members of the population. Marketers used to rely on telephone books, but we always knew that telephone books didn't include all telephones, and increasingly today they're even less representative. Lists of registered voters, another common sampling frame, and we know that those lists exclude certain kinds of people. Brand managers sometimes will use registered purchasers. Again, we know that not even half of purchasers register their purchase. So the frame we use is always an important question in drawing a sample. The reliability of sample just as it does with a measurement, refers to the repeatability. If I were to draw a sample of 20 and then redraw a sample of 20, would they be similar? The reliability is a function of population variance. Some populations are quite homogeneous on dimensions and some are not at all. For example, if you were testing for the presence of hazardous materials and you wanted to test a public water supply and also public lands, of course, water supply is very homogeneous. So you could take a very small sample of water and expect that that would be representative of the entire public water supply, because hazardous materials diffuse quite evenly throughout huge volumes of water. Soil, on the other hand, is quite heterogeneous. And so many samples from many different areas would be required to have something that represents the entire body of public land. And that issue applies to humans as well, and whatever aspect of humans we hope to measure. And of course, sample size affects repeatability. Again, with a population of 100, a very large sample, 99, is apt to look like any other sample of 99 because, in fact, 98 members of those 99 have to be the same. So the larger the sample size, the more valid and the more reliability that sample will be. A chief concern of sampling is the effect of sample and sample size on the confidence we have about the estimates we're making for the population. In measurement theory, the essence of measurement theory is that any measure comprises two components, a true score and an error component. And that's true when we use samples to estimate population parameters. The sample mean for a parameter is a measure. It's an estimate of the population, but it's our measure of the population. And so our estimate is a population mean plus some error component. And that error component translates into thinking about these estimates with confidence intervals. So we guess that there's some error, and that error is a plus or minus component around the mean of the sample, and that comprises the confidence interval. Now, the size of those confidence intervals depends on two factors: precision and certainty. Precision is how big the plus or minus component is, and certainty is how confident we are that the population parameter is actually in that range. And those two are trade-offs. The more confident we want to be, the more certain we want to be, the less precise we'll have to be. And the more precise we want to be, the less certainty we can hold. Sample size affects both precision and certainty. The larger the sample size, the more precise we can be, or the more certain we can be that the sample estimate is a good indicator of the population parameter, or both could go up somewhat. The population variance, so that the distribution of this value in the population lowers our ability to precise and certain. So populations with low variance help us to be more precise and more certain. Populations with high variance result in our being less precise, and less certain. And finally, as mentioned earlier, if we want to have subsamples in our sample size, if we have control variables or category variables, and we hope to break the sample down and compare young, intermediate, and old age groups, for example, then we're necessarily cutting down the sample size into halves or into thirds or into quarters, and that will lower our precision and certainty for any of those comparisons.